and we'll talk about it. The Dead Sea Works is the Dead Sea Works is the number one world producer of bromine. Bromine, you know, you study agriculture, right?
Yeah.
Okay. The number two in the world, in the Western world, in metallic magnesium. Okay. Number six in the world in potash. This is the white fertilizer that you see there. In order to understand a little bit about the logic of the production here, you have to understand something about the Dead Sea. So you can see a satellite map of this area. You can see the Sinai Desert here, the Gulf of Suez. Here is the Suez Canal, the Gulf of Eilat. Here is the Dead Sea, which is the lowest region on the face of our planet, the Mediterranean, the Red Sea. And the Dead Sea, which is the lowest region on the face of our planet, you come from the highest country, right? Nepal. So, as the lowest region, it is part of a long and narrow valley extending from Syria, Lebanon, Israel, the Red Sea, and it goes into the center of Africa. And this is why it is called the Syrian African Rift area. Until the State of Israel was established, the Dead Sea was, as the lowest region, it was getting water, fresh water, from many large distances, bringing with them very little minerals. But as the lowest region, water can come in, but out it can go only through evaporation. So the concentration of the minerals increased gradually until it reached 34-35%. This is the maximum possible concentration of mineral. And how is it called in chemistry? Anybody knows? It is a level of saturation.
Super saturation.
Okay, it's the saturation. It's if you take salt, afterwards you will bathe in the Dead Sea. So if you take salt from the kitchen and you pour it into the water, it will not dissolve, it will sediment. Okay? As I said, until the State of Israel was established, the Dead Sea was more or less at a steady state between water flowing in and water evaporating. You can see a map of the Dead Sea. You can see the northern part here is long and very deep. It's down to 300 meters deep. The southern part, where we are now, is very shallow, not deep, less than 10 meters, natural depth. So, when the State of Israel was established, the Dead Sea was more or less equal between water flowing in and water evaporating. In rainy years it went up, in dry years it went down, but generally we can talk about a steady state. And when the State of Israel was established, 1948, this steady state ceased to exist. What happened? Israel needed to settle the south part of our country from Ashkelon southwards, which is desert. So water had to be brought from the outside. Israel built a water project taking water from the Sea of Galilee in the north, diverting it to the south. This was necessary because half of our territory is desert. So this project, which is called National Water Carrier, started its operation 1964. The Dead Sea was getting its water from many long distances, but the major part of the Dead Sea supply comes from the Jordan River, which comes from the north, and when the national water carrier started its operation, the amount of water reaching the Dead Sea through the Jordan River was cut by 90%. So now more water is evaporating than coming in, and now the water level in the Dead Sea is dropping about 1 meter every year. Since 1964, when the national water carrier started its operation, the water level in the Dead Sea dropped by about 45 meters. Okay, 45 meters is not that difficult, it's not that problematic to the northern part because it is still very deep. But the southern part is very flat, very shallow. Here you see the upper map. You can see this map represents the Dead Sea in the 1930s. Okay, please come closer. Okay. Okay. So you see that the south part is connected with the north part. In the 1980s, you can see this map. Here, the south part is formerly dry because the water level dropped already very much. And here you see the Dead Sea in the 1990s. I mentioned that the southern part is less than 10 meters in depth. So the water dropped by 40 meters, which means the south part is dry, but it's not dry. In order to prevent the drying of the southern part, a canal was built taking water from the northern part to the southern part. And with this canal, the water level in the south is artificially regulated. Okay? So, what you can see is these three maps, 1930s, 1980s, and 1990s. What can you say about the dark blue area? What can you say about the dark blue area? Decreases. It's getting smaller, right?
What is the main reason of decreasing?
Well, it is getting smaller. So with this, the amount of water evaporating is also getting smaller. Okay? Many people are worried that the Dead Sea will vanish, will disappear. But it's not going to happen because as the water level drops, the Dead Sea becomes smaller. So the surface area is smaller, the amount of water evaporating is getting smaller. So it is estimated that in about 100 to 150 years, the water level will stabilize, okay? And the amount of water coming in will be equal to the amount of water evaporating. And then in about 100 to 150 years, under the present conditions today, we will have a smaller lake than today, larger than the Sea of Galilee. Its depth is going to stabilize at 100, 150 meters compared to 300 meters today. This under the assumption that there will be no global warming. Nowadays everyone is talking about global warming. Earth is getting hotter. There are some disputes about that, and that there will be no project bringing water from the Mediterranean to the Dead Sea or from Red Sea to the Dead Sea. Under the present conditions, this is what is to be expected. So far, any question? Do you have any question?
We see this.
No, I will talk about the industry. Only a question about what I asked, what I talked.
The water evaporates only, or water comes from other sources also in the Dead Sea?
Yes, the water comes from rains, from rivers, from wadis, creeks, springs, and from underground water that seeps into the Dead Sea. But a major source of the Dead Sea was the Jordan River.
Jordan.
Okay.
It can't be.
And it is now 90% cut. Okay, only 10% of the Jordan River is coming to the Dead Sea. The other sources, more or less the same. Okay, But this is the reason why the water level in the Dead Sea is dropping.
The Dead Sea will disappear on in
No,
future?
this is what I said, that under the present condition, the Dead Sea will become smaller, the amount of water evaporating will also become smaller, and will come a time that the amount of water evaporating will be equal to the amount of water coming in, so the water level will be stable.
If water doesn't evaporate, then water also
The water
becomes-
will evaporate,
water
but
level also
no, the water will evaporate, but the amount of water coming into the Dead Sea will be more or less equal to the amount of water evaporating, and then the water level will be stable.
So we need to increase the source of water for Dead Sea, yes?
If we want the water level in the Dead Sea to rise,
Yes.
but under the present conditions, it is going down about 1 meter every year.
Okay.
About.
So there is no possibility to disappear the Dead Sea, right?
To what? No
There is
possibility
yeah,
to do what?
to banish Dead Sea.
To
No,
finish.
no. The Dead Sea is not going to disappear. Under the present conditions, it will keep going down another 100 to 150 years, and then we will have a smaller sea than today, but it will be stable. Its depth is going to be 100, 150 meters compared to 300 meters today.
it's going to be like a lake, small lake.
A lake, it
in-
will
in
be
future.
smaller, yes,
Okay.
but stable.
Stable.
Okay, now the industry here is established already in the 1930s, end of the 1920s, and the idea was to separate the minerals that are in the water. How do you separate the minerals that are in a solution? You evaporate the water, and each mineral will crystallize and sediment at different times. Okay, so the first mineral to sediment is sodium chloride, NaCl. This is no interest. It sediments in the north, and the other minerals, the interesting one that contain the potassium chloride, KCl, which is potash. This is the major product, and magnesium chloride, bromides, and other minerals. They flow to the south, and here the sun evaporates the water, and the minerals sediment on the ground. Now, imagine if we evaporate all the water, eventually, then we would have to take the raw material from the ground, just like you see here. This picture is taken 1934. Okay, imagine after you get rid of the sodium chloride, you let the raw material, which contains potassium chloride and magnesium chloride, sedimenting on the ground. This is the white material that you see on both sides of this trail in the water. Most of the raw material sediments at the bottom of the pools, of the evaporation pools. Imagine at the beginning, in the year 1934, they evaporated all the water and collected the raw material from the ground, as you see here. Imagine to work in July, August, which is very hot, in this white surface. It is really very difficult work. So the engineers of this company started a new idea. They said, instead of evaporating all the water, we can evaporate only half of the water, and then it will be enough for the raw material to sediment on the ground, and we will collect the raw material by a boat like this. It is flat, and it has a spiral screw at the bottom, just like your parents have in the kitchens. The meat machine. You turn it, and it's called the Archimedes Screw. Okay, and you grind the raw material from the ground, and you pump it with water, with pipes and pumps, all the way to the plants. The same idea is done now today, but this is the first model, version 1. Okay, you see it's a boat made out of wood, but the idea is the same. You see, 1, 2, 3, and there are nine boats like this, and they work 24 hours a day, 364 days a year. Okay? Each boat can forward 1,000 tons every hour.
Why not in one day?
What did you want to say?
164, only 164 in a year.
I'm sorry?
164 days in a year, and that one day.
I didn't understand the question.
In a year, that he said that 364 days he worked that all boards for one day. Why can't do the work?
Why?
Well, one day. Why one day? Because we have one holiday, the Day of Atonement, Yom Kippur, which it's not possible. Okay, but besides that, it works all year round, 3 shifts, morning, afternoon, night. Okay, all the time. And the major product of the Dead Sea Works is this white material that you see here. It is called potash, KCl. You study agriculture, you learn about fertilizers. Nowadays, the world is being even continuously more populated. The population increases. The open areas are decreasing. So we must replenish the minerals in the soil. Okay? And we have here an endless quantity of minerals for whole humanity. Why? Because for example, in Canada, they are the major producer of potash. They take it from underground. Whatever you take out is gone. Here, whatever we take out, the next year is completely new, because the minerals come from very large distances and they come to the lowest level. That's why we have a renewable source of minerals. Okay? The last product that was made here is magnesium. You can see there in the south, you can see a plant with a yellow color and a white and red chimney that emits vapor, water vapor. It produces metallic magnesium. You can sense it. Okay, I will talk about it when we will be inside. You can pass it around you. Magnesium is a light and
But it's very light.
very light and soft.
So light and soft, yeah.
Light and soft, but
It's very strong. Yes?
if you mix it,
It's very strong.
no, it's not very strong. It's soft. It is
Yeah.
soft. You can use a file and it will rub. It's not very strong, but if you mix it with aluminum or with iron, then you get a very strong and light metal.
Especially this type of metal, they use the car companies. They use like this. Yes.
Exactly. Yes, but it's not pure magnesium because this is flammable. You can ignite it. It will fire. It will burn very quickly.
Okay.
But if you mix it with aluminum or with iron, then you get a metal which is very soft. That's why the major partner of this company was Volkswagen. You heard about
Volkswagen.
Yes.
Volkswagen. Okay. All right. Now, in between the potash plant and the magnesium plant, we have a whole series of different plants. You see there a plant with blue color. The plant with the blue color is the #1 plant in the world producing bromine. Bromine is a chemical from the same family as chlorine, iodine, and it has many applications. I will talk about this when we will be inside. Okay, the total amount of potash that the Dead Sea Works is producing, number 6 in the world, is 3.8 million tons of potash. If we have to transport 3.5 million tons from here to Ashkelon, to Ashdod, we will have to take double trucks, each carrying 50 tons, 70,000 times, back and forth, back and forth. So, since about 35 years ago, the Dead Sea World built a conveyor belt. You see there, like a pipe going up. This is not a pipe, but it's a rubber band, 1 meter wide, 18 kilometers long. It goes from 400 meters below sea level to 600 meters right next to Dimona, loaded on the train, and from there to the harbor. Okay, this is really a technical and engineering achievement. It operates successfully over 35 years now.
Yes.
Okay, any questions? All right.